This lesson is going to talk about solving inequalities and then graphing them on a number line to indicate the numbers that are solutions. So let me refresh a few memories here in regard to less than and greater than signs. If the less than greater than sign is in the problem, when you graph, you're going to use an open circle. And that will indicate then that the circle number on the number line is not part of the solution to that inequality, as opposed to a less than, greater than, and equal to sign. So less than or equal to or greater than or equal to. When we graph those, we're going to use a closed filled in circle. And that will indicate that the number that that filled circle is on is part of the solution. Let's look at these examples. X is less than 3. So the open circle is put on 3, and then the arrow is drawn to the left, indicating these are all the numbers that are less than 3. The open circle indicating that 3 is not less than 3. At the same time, x is greater than or equal to -5. Circle is put on -5, filled in to indicate that -5 is included or greater than or equal to -5. And keep in mind, numbers that are greater than -5 go this direction on the number line, so it would be -4, -3, -2, and continuing into the positives. Here's an example. 2x is less than 8. First thing you need to do is solve for x. Similar to the way we solved equations, except these are inequalities. Same process. Divide by 2 on both sides, and you would get x is less than 4. To graph, open circle on 4, and draw the arrow in the direction where the numbers are less than 4, which would be to the left, going towards 0 and then into the negatives. Here's another example. Solve. 3x minus 1 is greater than or equal to 8. This is two-step equation solving. So you're going to add 1 to both sides, just as we did with those equations, and then divide by 3, and you get x is greater than or equal to 3. Fill in the circle and go to the right, because those are the numbers that are greater than 3. I'd like to talk about this example. This example is -3x is greater than or equal to 6. Let's look at some possible values for x. Let's think, would -4 make this inequality true? -4 times -3 is a positive 12. Is 12 greater than or equal to x? Yes. -3. -3 put into this inequality, that would be 9. Yes. -2 put into the value of x times, yes, that would equal positive 6. -1. -1 times 3. -3 is a positive 3. That is not greater than or equal to x. So this is not a solution. 0. 0 is greater than or equal to 6. No. And I think you're going to see a pattern now when you try 1 and 2. Now there's a rule I want you to keep in mind before I go on to the next example, or into that example. When multiplying or dividing by a negative number, you need to reverse the inequality sign. Here's what happens. Taking that same problem, we're going to divide by -3. And here I did that. When you do that, dividing by -3, we need to reverse the sign. So it started as greater than or equal to, and you're going to make it a less than or equal to. If you remember, when we were testing these numbers, the -4, -3, and -2 were solutions. However, the -1 was not, as well as these numbers. And that proved true. X is less than or equal to -2. So those were the solutions. And again, that shows you that you did need to reverse this inequality sign. Here's another example. -2x plus 7 less than 19. Again, solving these similar to equations, we would subtract 7 from both sides of the inequality and divide by -2. Again, dividing by -2, I'm going to reverse the inequality sign. So this solution is x is greater than -6. To take the -6 You put an open circle there. Numbers greater than -6 would go to the right. Now to check, there's a couple things you could do. You could choose a number. Let's choose -7. If we put -7 into this problem, -7 times -2 is a positive 14. 14 plus 7 is 21. Is 21 less than 19? No. So those are not the solutions. And if you tested a number on this side that you graphed, let's take -5. -5 times -2 is a positive 10, plus 7 is 17. 17 is indeed less than 19. So that we did take the arrow in the right direction. Let's look at this example. This one I selected because there is a variable on both sides of the inequality sign. So again, we need to go back to our problem solving. Let's add 7 to both sides of the inequality, and then subtract 11x from both sides to get the x's onto one side of the inequality. Divide by -7, and again I chose another example, again dividing by a negative, reverse the sign. That's an important step to remember. So the answer is then x is greater than -2. Again, you put the circle on -2 right there, and it does not have an equal sign, so you keep that open. Numbers greater than -2 would go to the right. Again, you could check. We could select a number. Select a number on either side of the inequality. 0 is an easy one to test. Let's take 0. If we put in a 0 for x in both places in the equation, this would become 0, and this side would have a -7. If we put a 0 here, this side would have a positive 7. Is -7 less than positive 7? The answer is yes, so we went the correct direction. We could test another number if you weren't sure. We could test 1. 1. 4 times 1 is 4. 4 minus 7 is -3. And then 1 here is 11. Plus 7 is 18. And sure enough, -3 is less than 18. Keep in mind, this arrow is indicating all the numbers that are solutions for this inequality. And at the same time, the numbers that are not in the graphed area are not solutions of the inequality.